Yeah, so if we have question 16.29 and 30, I think I did this in office hours, not this Friday, but the Friday before. We're asked to find the concentration of HF. So after we add 5 milliliters of a 0.01 molar HCl solution, I add that to 25 milliliters of a buffer that contains 0.1 molar potassium fluoride and 0.2 molar HF. So the first question for question 29, what is the concentration of HF after the addition of 5 milliliters of that? So for this calculation, we do need M1V1 equals M2V2 because we're mixing together, right? I'm mixing together two different volumes. So let's find our new moles of HF and our new moles of potassium fluoride and HCl. So for the HCl, potassium fluoride and HF. So for HCl, right, my initial concentration is 0.01 molar. My initial volume is 5 milliliters, right? My new concentration is what I'm looking for, and my new volume would be 30 milliliters. For potassium fluoride, 0.1 molar, and I have 25 milliliters. I want to find my concentration when I mix the two together, and I'm up to 30 milliliters. And with the HF, I've got 0.2 molar, 25 milliliters of that, and I'm looking for the concentration at 30 milliliters. So go through, do the calculations for all of that. All right, so I get 1.67 times 10 to the minus 3 molar for HCl. 0.1 times 25 divided by 30, and I get 0.083 molar potassium fluoride. 0.2 times 25, and then divide that by 30, and I get a 0.167 molar HF. Right, so now we can set up our little buffer table. And so for the acid, for HF, I've got 0.167 molar HF, got 0.083 molar potassium fluoride, right, the conjugate base of HF. And then to that, I'm going to add the strong acid. I'm going to add HCl. And how much HCl? Right, 0.00167 molar HCl. The HCl is going to react with the conjugate base, the fluoride. It's going to protonate the fluoride, forming more HF. So we'd expect to see the concentration of HF increase and the concentration of potassium fluoride decrease. So we're going to subtract it from the potassium fluoride concentration, and we're going to add it to the HF concentration. So 0.083 minus 0.00167, right, to get my new concentration there. So this concentration gets a little bit higher. This concentration gets a little bit lower. Right, so my new concentration here becomes, not a whole lot different, right? 0.0813, and then my concentration 0.167 plus 0.00167, not a whole lot different. Yeah, pretty much 0.1686. So we'll say right, HCl reacted, we found the new concentration of HF based on that. So now we've got question 29, where I would say the three significant figures, right? 0.169 molar is my concentration of HF. Now we can find the pH of this solution, because the pH of this solution, anytime we've got a buffer, we should think Henderson-Hasselbalch, really. That's the key equation. So pH equals the negative log of my Ka plus the log of the concentration of my base over the concentration of my acid. So the pH of this solution, the negative log of my Ka, I think it's 7.2 times 10 to the minus 4 is my Ka of HF plus the concentration of my base, 0.0813, the concentration of my acid, 0.169. So the new pH of this solution, all right, negative log of 7.2 times 10 to the minus 4 plus the log of 0.0813 divided by 0.169. All right, I get a pH of like 2.82 for that system after we add the HCl to that. All right, so M1V1 equals M2V2. We had our buffer, we added a strong acid to that. The volumes changed, so the moles changed, and we had to find our new concentration of the new volume, and then basically say, okay, the HCl reacts with the conjugate base, that concentration goes down. The product of that reaction is more of the weak acid, that concentration goes up. And then from there, we can find the pH of that buffer.